Building distributed systems is not getting easier, and we need the right tooling to understand what is happening. We know that where problems manifest, where we experience them, either as end users or as service owners, SREs, or whomever, is not necessarily the place or the root cause of that problem, right? So if I own service A, it very well might be the case that the source of my problem could be on service XYZ, which is 7 hops away. So we need a way, we need software that can provide insights that are meaningful and actionable. We've all experienced the problem of dashboard fatigue, looking at a ton of data, but really then the kind of responsibility being on us to infer what that data does. So I'm going to go through a walkthrough of Lightstep in this video, show you our take on solving problems in distributed systems. We're a very opinionated platform, which is why we are the best at what we do. Now, the application that we're looking at today is an e-commerce platform. There is an iOS client, there is an Android client, as well as a web client. All of those requests go through an API gateway, and then behind our API gateway are a suite of services for doing e-commerce stuff, right? People need to log in, authenticate, they need to buy things. As part of buying things, we have an inventory service that checks if we have inventory. There are database tiers, right? Handling transactions, purchases. So even though we have a standard e-commerce application, what we end up with is 15 to 20 services, right? And that is kind of the standard for software development today. Obviously, there are a ton of benefits to being able to individually scale a service as throughput or resources required by that service increase, right? So let's go ahead, jump in, stop looking at my face, and look at some Lightstep. Okay, so we're now looking at Lightstep. I wanted to start with the service diagram, really to show you the architecture of the system that we're looking at. One of the really powerful things about Lightstep is our ability to dynamically draw this diagram for every query that you run. So we're in Explore, the tab that I'm in right now. If you look at the left side of my screen, I'll hover my mouse over it. We're in the Explore tab. For an empty query, I get a general service diagram. So we can see those 3 different client services I was talking about, our web service, our iOS service, and this Android service. They go through this API gateway. There's this Apache service floating over here on the left. There's a store server in here and a suite of other services, right? As I query things in Lightstep, Lightstep will do a real-time analysis of this trace data, or we can even think of these as transactions, and show me the service diagram relative to that query. So right now you can see I've selected this iOS service in our dropdown, and because I'm more business minded and focused, I really want to see what the performance of this service is for one of our top customers, this ProWool customer. They're actually 60% of our business, and I want to see how it's performing for them. Now, obviously we care about all of our customers, but this is really how people problem solve, right? We all have kind of a top-down directive to optimize our systems towards our business goals. So here we can see a distribution of yellow across our diagram showing the aggregation of latency, time spent, the bottleneck, however you want to think of it or word it. We can answer many different questions with this view here, but we can see relative to our iOS client and this one customer, most of our time is being spent in this warehouse service, as well as a little bit on our inventory service, and a ton down here in this SQL inferred services. We have the ability to infer services via some configuration in Lightstep, but really the idea there is if you're depending on third-party services or uninstrumented entities in your environment, we basically have a way to show their latency contribution versus the calling service itself. So really just wanted to start here as an overview of really our ability to just look at your system as a whole and drill in from there. What I want to do is, because I'm a service owner of this warehouse service here, where we see there is some latency, right? And I've actually been told by my manager that there is a spike in memory on the service, and I'm not really sure why. We can see here that the ProWool customer, relative to them, there is a bit of latency there and a ton of latency downstream on this SQL service. Let's actually just go look at the metrics for our warehouse service. So I'll go to my dashboards tab. I'll do a search for warehouse, and let's look at our warehouse health dashboard. So now we're looking at metrics. This is something that most engineers are familiar with. These are all metrics, right? Your counters, your gauges, custom metrics. We support all of those in Lightstep today. And what's really powerful about our platform and where we sit above our peers in the space is our ability to connect the dots from your metrics data, which are just signals, right? We can tell when we're using more or less of some resource. There's more transactions. There's more of some status code, right? And we can connect that to the context that exists in trace data. Now, if you're not someone who is familiar with tracing, just think as a trace as a distributed call stack. So every single thing that happens in your system, we can connect those dots, not just at the edges, but inside of your services too. In any case, let's focus on the graphs that are here on our screen right now. We can see here, there's this spike in memory that my manager was telling me about, right? There's a huge increase in memory utilization, or at least there was earlier in the day across, it looks like every single one of our hosts in our memory service. It's really up to me to figure out what this causes. And again, or what caused this. And again, it can be hard. And I know this for a fact because I've spoken with and met with and really have been problem solving with, hundreds, if not maybe more of engineers in this industry today with systems just like this. What we can do in Lightstep is I can just select this deviation and choose what caused this change. Immediately what happens next is really cool. Behind the scenes, because we have trace data in this environment as well, we can see now how transactions going through this service are impacting the metrics for this service. And what's really cool about that, and what's more, I'd say, useful to me as an engineer in this case, and how I can report this to my manager, is this is in the context of the entire system now, right? But let me actually show you what I mean by that. So we'll scroll down here. We're looking at a warehouse service at the top, and this is ordered by magnitude. There's this update catalog operation. We can see its changes in performance. So its P95 of latency went from 146 milliseconds up to 513 milliseconds in this context. There was an increase in rate from 11.93 operations per second up to 19.16. So that's about a 100% increase. We'll give or take a few percent there, right? In terms of order of magnitude. And see the error percentage is flat. So things aren't breaking yet, but they certainly have degraded at the same time that our memory utilization has gone up. So what is happening here? Well, let's look under the most likely causes of performance changes. So really what we're looking at here is in the context of these particular traces, there are tons of different transactions / traces going on in our environment, which means that there are many different permutations of events, right? Just because I have a service doesn't mean that there's only one way that the service is being interacted with. There could be tons of ways that my service is interacted with. Lightstep handles all of that thinking for me, and it's telling me these things on the left side are correlated or driving this change here. So I can see there's this customer of Prowl again, our money maker. They were 5% of the traces in our baseline, 42.9% of the traces in our deviation, and clearly an outlier in this data set. They're at the top here of this output. So I'll select into that. It looks like they are driving a lot of the transactions that are knocking this over. Lo and behold, here's that iOS service again. Think of this as kind of a critical path analysis. So the question becomes in a distributed system, what are the services that I need to care about? And ultimately, who are the service owners that I need to call? If you've been in this industry for a while, you've probably been in a war room or some similar type of on-call triage scenario where yourself, other engineers, people in operations on the business, you all put your heads together to try and figure out what is the problem, what do we need to tell our customers? And really our goal here is to make that as fast as possible, but also reduce the amount of resources. So in this case, we can see it's just transactions coming from our iOS client into our warehouse service. And so we could ignore kind of all of the other permutations or types of events, interactions in our system, right? In any case, we have a breakdown of these traces here, or transactions. I use transactions a lot in this case because that's how I like to think of them in the context of our entire system. We can see the P95 of latency has went from 181 milliseconds up to 887 here on the right, highlighting now, increase in operation rate, etc. So I went from a signal, right, metric, looking at memory utilization, and now I kind of have an understanding of what's happening within the scope of my entire system, which is really what we're always trying to do when we're problem solving, right? If I'm at an organization with 20 services and 20 teams, or 100 services and 100 teams, this becomes critically important. And if you're a service owner or someone who's been doing this for a long time, you definitely understand that. Behind all of this are the individual traces themselves. So we'll jump into one trace. And this is what we're analyzing at scale. If you're new to tracing, and this is your first time looking at a trace, sorry it took us this long to get here, but I'll break it down for you now. Again, a trace is comprised of spans. A span is each row on our screen here. A span has a name, how long it took, right? In this case, this update catalog operation is the name. It's API update catalog. It took 1.25 seconds, and it ran on the iOS client service. So a name, the service it ran on, and how long that took. And a span is really a unit of work. They can be any size, right? So it can be this request. It can be the request handler, like we see right below it. It's direct child on our API gateway, endpoint, however you want to think about it. This took 1.23 seconds. It depends on some other work, right? It called another function that took 48.6 milliseconds. This called another function, which took 17.8 milliseconds, so on and so forth. Basically, all the things that happen in our system get turned into spans. We measure them. What's more powerful about that is if we look on the right side of our screen, the metadata attached to this, right? So even within this one trace, we can see how this becomes immensely useful, right? There's a user ID that this transaction was for, a resource ID, customer names, catalog IDs, all of these different spans as I click through here. This customer pro here on the right side here for this top span is a part of this. The span can also have any number of log events. We're very opinionated about logs over here at Lightstep, but your logs become much more useful when we attach them to traces, because now I know, again, we're looking at this beginning span on our iOS client. I know the exact payload that was sent with this request. And if I'm someone who owns this warehouse service downstream, I know that this specific payload is directly tied to anything and everything that happened down here, right? We can see this particular database statement. So your logs immediately are all much more useful. And if you attach all of your logs to spans, the entire tool set that our industry has relied on, when you think about, the effort of I'm looking at one log, I need to know how it's correlated to these other logs. A trace really is just a distributed log, and your inline and your runtime logs, all of your stack traces and everything are always in context. They always are where they need to be. You don't need to go and connect the dots later and have this complex tooling, log data bucket, that you're spending a ton of money for just to hold on to a bunch of logs so you can try to connect the dots later. All that disappears. In any case, that is what we call change intelligence, something we're very excited about, and our customers are too. Let's move on to doing root cause analysis with some trace data. So I'll go over to service directory. So I'm over here in service directory in Lightstep. This is the home page when you come into Lightstep. So we can see all of our services on the left side of the screen. In the middle are the SLIs for each service. These are graphs that we generate out of the box as soon as you come in. And on the right side, we can see an expanded version of the currently selected operation, or we can see SLIs for the currently selected operation. So what can I do from here? The same thing that I want to do when I'm beginning any root cause analysis scenario is from the perspective of the thing that I own, right? And this is key here because I don't always know where to start, but I know what I'm in charge of. I know what I own, and I ultimately need to get down to the root cause, right? So we can see there's this update catalog SLI, right? Its latency graph here on the right doesn't look good. It looks like we had a problem earlier. And if I want to, I can zoom out from the last 60 minutes to 4 hours. Again, it's up to me because we're at a small company and I wear many hats. I also own this service. Go figure, right? And I need to know what is causing this, right? So we're experiencing latency on the front end. If you've ever worked on front end software, you know that that's probably not where the root cause is, but it's really easy to figure this out in Lightstep. I can just select this, choose a baseline to compare it to. In this case, so our analysis window chosen in yellow, baseline chosen in blue, and then I'll hit view comparison. This is really super fast and simple. I get a few, really 4 primary outputs on this screen. And we'll go from the top left to the bottom right. The first is a latency histogram. If this is your first time seeing this, it's just a distribution of these spans, this operation or this unit of work. This unit of work in this case is our update catalog request, right? So scrolling back down here, our horizontal axis is time on a log scale. Our vertical axis is number of spans, number of update catalog requests, right? Also on a log scale. So as we move further to the right and higher up on our graph, things are getting slower and slower, and we're looking at more and more of them. On the right side, we see this compare attributes correlations table. This tells us the things in this context that are driving latency. So looking at our latency histogram with this blue baseline, the things outside of our baseline in are in yellow here on the right. We're trying to figure out what is causing this stuff here on the right. Why do we have this set of data outside of our faster blue band here, right? Lightstep is telling me that 317 milliseconds of that is correlated to this customer of Prowl. Again, Prowl, they pay us a lot of money, but we should talk to them. It seems like they're really messing our system up. In any case, scroll down, look at our operation diagram. This is very similar to the service diagram that we started with, but at the operation level. So every operation going across service boundaries, we can see here, there's this update catalog operation, calls into our API gateway. Downstream from our API gateway, it looks like there are 2 kind of primary code paths here across our service architecture. So I'll just scroll down to the bottom right. It looks like a lot of our time is being spent doing this write cache operation and this database update operation. So this is very powerful in, again, narrowing my search scope. I know it's not the API gateway. I know it's not authorization, right? Any of this path on the left, I can rule this out. I now know I need to focus on my warehouse service. I can reach out to the warehouse team if I wasn't the warehouse service owner, which in this case, I'm already wearing both of those hats. But you see kind of the benefit here in being able to always have contextual analysis. This is very different from just looking at, aligned time series, and more so being able to say, hey, you should go here. You should reach out to this team. Focus your efforts here. The last view on the screen is this compare operations table. This is really just this diagram on the left in empirical form. At the top, we see write cache, and right under it, we see this database update as our 2 primary drivers of latency. So I've went ahead and selected that write cache operation, and we can see here that I'm now looking at all of the logs kind of rolled up within the context of this RCA view here. And I can see here that they all have this event of beginning cache write with items in the range of 100 to 2,000. So makes sense. It seems like we're doing large cache writes in this case. We're spending a lot of time on our cache write service. That's just an expensive operation in general. There's tons of ways we could fix that. We could unblock on this. However we engineer the solution is almost irrelevant, which is really important. And again, thinking about how we problem solve and work in engineering teams is following up with our customers, right? Understanding what the problem is so that we can set expectations with them as quickly as possible, and they know what are their level of service that they can expect coming into their next business day, whatever the industry is, right? So whether we're customer facing retailer, like we are here, an e-commerce platform, our customers might be another business that is relying on our APIs, and their primary concern is going to be, understanding what level of service they can expect. And the faster that we can do root cause analysis, the faster we can come back with those positive business outcomes and directives. So we focused so far on proactive analysis. We're now going to switch into the alerting side. We're now looking at the creation of a metric alert here in Lightstep. I can give it a name. We'll just say this is a demo alert. I can give it a description and immediately query some metrics. So in this case, I want to know anytime iOS request, or we'll plot another metric. Let's say Android request, or we'll plot another metric. Let's say web request, right? Any one of these. If you scroll down here, we can see how these are plotted on this graph. Let's just say any one of these is above a value of 6, right? So we'll put 6 here in this critical threshold box and scroll down, and we can see where that alerting threshold is. Now, I did that pretty quickly, so let's go top to bottom and see what I've configured so far. In the top here is my first query looking at in-flight iOS request. Represented this as just the latest value. It's aggregated by the sum. And I've done the same thing for in-flight Android and web requests. If I want to make this more interesting for each of these, I could do a group by on customer. Let's say group by on customer and a group by on customer. There are a number of different ways that we can actually look at these values. We can look at a count of the values, the rate of these values, and our aggregation can be changed as well. Instead of the sum, we can look at non-null values, maximum values, the mean or average of those values, minimum value. I'll leave it at the default for now. And I also could add these time series together using a formula, but I won't in this case. I think I actually hit that button earlier, so we'll get rid of that. So if I go down to my time series now, we can see that because I've added these group buys for each customer, this is a little bit more, I'd say less alerty, right? We see that it would have alerted here, but our time series is more interesting. Where do I want to send this alert, right? So in Lightstep, we have a few integrations out of the box. There's a Slack integration, there's PagerDuty integration. We have this webhook option, which essentially lets you integrate Lightstep with, your alerting tool of choice. I can change my threshold. In terms of alerting itself, if we look at alert configuration, scrolling back up, I can send a single notification when any one of the values in my group by exceeds our threshold. I can send separate notifications for each group by value when it's above or below that threshold. And then I can change kind of the interval of time and how we're looking at the values in that time for our alert. Really, this should be straightforward to understand and use if you've used metrics tools before. Our goal here really isn't in just giving you alerts, though. It's about what we do next, right? And that is the change intelligence, the workflows that I did before. You'll notice in Lightstep that I can initiate change intel from anywhere. I can immediately jump into what caused this change, and that would bring me into that analysis. So when this alert fires, or if it was firing, it wouldn't be right now, I can immediately jump into and do root cause analysis just like I did earlier. And that is really the primary focus. Alert configuration and all that is straightforward and I'd say standard in our industry. Let's look at trace-based alerts. So we'll go back to Explore. This isn't the only way to do this, but we'll start from this view. Very often when we're looking at something in real time, if there's some interesting query, say I'm looking at the performance of my iOS client, and I'll look at this one operation and I want to slice it by this one customer of ProWool again, right? So I'm looking at this view in real time, have real-time analysis looking at 100% of my data, which is great, by the way. It's awesome that I can very quickly understand correlations on the right, what is slowing things down. I can investigate all of these spans. But what if I want to look at this over time and alert off of the performance of these transactions in particular along this one operation path over time? We can use a stream for that. So I'll hit view stream. This brings me to a stream for this data. Now, I've created this stream a long time ago, so we have the streams. The retention on streams is 2 years kind of as a standard in Lightstep. But what we can do with this is alert off of these values. And really the use cases here and why this is so powerful is instead of saying, hey, hey system, send me an alert whenever this thing is slow, I can say, hey, send me an alert when it's slow in this region. Send me an alert when it's slow for this customer, for this service version, for this specific, A/B test, across these set of services. It could be just this customer in this region, for this credit card processor type, right? There are tons of different ways we can slice our data. Really, there's any way we can slice our data, then we can alert off of those things specifically. I'll hit the alert button here now. We can see that there are 2 configured here. I will go ahead and hit the create an alert button. We can alert off of latency, error percentage, and operation rate, any of the values on this screen, and we have the same destinations as before. So what is actually on our screen? We have a stacked graph of latency, rate, and error percentage. We have our P99.9 graph through our P50, and all of these green dots are exemplar spans. So if I just open one of these up, this will bring me into that trace in this time series, which is, we see here, this get transactions operation, for this one customer of Proble, right? Exactly what I had made my query before, setting up my stream. Wow, so that took longer than I expected, but I wanted to make sure I got through most of our primary use cases in this demo. If you have a use case that I didn't walk through today, please let us know. You can reach out to me. My email is forrest@lightstep.com, or you can contact and follow up with a rep or whomever sent you this video. Lightstep, again, we're an observability platform. We're really focused on insights on your data, right? Always contextualized specifically in distributed systems. That's what we're the best at, and we are the best at doing that. Thank you for taking the time to watch this video. My name, again, is Forrest. I would love to interact with you, talk to you about observability, and I know that the rest of my team would too. Thank you, and see you in the next one.